Welcome to question 6 of the 2007 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 6 we have two events A and B from a given event space are such that the probability of A equals 1/5 and the probability of B equals 1/3. For part A we're asked to calculate the probability of the complement of A intersecting B when the probability of A intersecting B is 1/8. So to answer questions like this, I like to set up a Carnot map. So a Carnot map will have A and the complement of A, B and the complement of B. And then we put that as a table. And next we want to put the information we know in there. So what we're going to do is get a common denominator for all of these fractions, which is going to be over 120. So 1/8 is equivalent to 15 over 120. 1/5 is equal to 24 over 120. And 1/3 is equal to 40 divided by 120. So placing this information inside a Carnot map, we have the probability of A is 1/5, which is 24 over 120. The probability of B is 40 over 120, which is 40 over 120 in this position. And the intersection of A and B is in this position here, which is 15 divided by 120. Now, the probability of A complement intersecting B is this box here, so that's the one that we need to find. And what we need to do is find a number that adds to 15 over 120 to give 40 over 120, and that is 25 over 120. Therefore, the probability of A complement intersecting B is equal to 25 out of 120, which will simplify to 5 divided by 24. So that is the answer for part A. For part B, we're asked to calculate the same probability of A complement intersecting B, but this time A and B are mutually exclusive events. So if we just quickly set up another Carnot map, we have A and A complement, B and B complement. And once again we had the 24 over 120 as the probability of A and 40 over 120 as the probability of B. And this time, if A and B are mutually exclusive, then there is no intersection. Therefore, the probability of A intersecting B is 0. So once again, the probability of A complement intersecting B is this entry in the table. And 0 plus 40 divided by 120 is equal to 40 over 120. So therefore we have the probability of A complement intersecting B is equal to 40 over 120, which simply equals 1/3. So that is the answer to part B of this question. For part A, only 31% of students got this correct, and those that did use a Venn diagram or a Carnot map usually obtained the correct answer. Many students either just added or multiplied the probability of A complement and the probability of B. Some students attempted unsuccessfully to develop a formula. Part B was likewise challenging for students, and there were a lot of incorrect attempts seen for the question. So in total only about 23% of students got the correct answer. A very popular incorrect response was 4 over 15, obtained by confusing independent events with mutually exclusive events. And this is a common error that you see occurring in the mathematical methods examinations. So students are reminded that independent events and mutually exclusive events are very different.